Hey guys, welcome back to another video. And in this video, we are going to talk about merge sort, how it works, and we will also implement merge sort without using any functions, straight, simple DSA concepts. And to make it fast and quick, I'll be using recursion. You can always follow an iterative approach, but because I found recursion pretty fast in this case, and the implementation is pretty straightforward, and you don't have to write all the big chunks of code. Although it's always that whatever you implement with recursion is always possible with normal method also, but recursion definitely saves you a lot of effort. And the idea behind recursion is that you keep repeating until you reach that one condition, which just is like return condition, and then you go out of the loop. So as you can see here, I have added specific arrays, and in like not specific, I have added one array, and I just put in some steps how the merge sort works. So like it works on the principle of divide and conquer, so it keeps on splitting it, and the split happens until you reach the very first point. And once you reach the very first point, so let's say 2 3 4 45 and then 4 8 6 3, and then this keeps like you again split 2 3 45 into 2 3 and 45, and then you again split 2 3 into 2 and 3, and this is how it works. And once you reach that, from there you do a comparison, element by element comparison. So say you compare the left half elements from the right half, and then you insert the result into the input into the final result, and you keep doing this for all the elements until you reach the dead end of either the left half array or the right half array. And once you reach the dead end of left half or right half, then you just concatenate the entire thing, and you keep on doing this, you keep on clubbing until you reach your final array. Okay, so that is the idea behind merge sort. And yeah, I'm sure you might be confused with many things. So if you see in this example, and we will be also walking through the code once we start writing the code, but if you see in this example 2 3 45 4 8 6 3, then it goes back, breaks 2 3 45 4, and then it goes 2 3. Here array size equal to 1, which is our boundary condition. It starts comparing from this point, and it checks, okay, 2 is less than 3, so I should put 2 first and then 3. And since the boundary condition of merging has also met, that is the left half has been exhausted, so it just concatenates the right half directly. So 2 3 in this particular example, because both of the halves have one element, so it is not clear. But if you go to the next step, which is 445, so it does the same for 445. So now we have one half which is 2 3, the other one is 445. We have the pointer is 0 for both the arrays. So pointer 0, so basically 2 is compared to 4, and because 2 is smaller, so 2 is added. Then 3 is compared to 4, again 3 is smaller, it is added. And now you can see that 2 3, like this particular merge condition has met, so the rest of the elements 445 are just appended or concatenated as it is, as you can see here. This is the spread operator, and those of you who are not familiar with JavaScript, this can be implemented into any language like Python. Spread operator in Python is equivalent to a star operator, so what you do is star of array, and that's it. That's the same thing is done by this JavaScript spread operator. So that is the idea. Okay, now moving ahead, we have like 2 3 4 5 2 3 4 45, and then we have 8 6 3, and because this will also be merged in the right half, so basically we start from the left, we keep on merging, and then we reach the right half. And so the flow is 2 3 4 45 is done, so we will move on to the right half, and then the merging will happen until this one reaches its the size of this array goes 1, and then it will keep on doing this, and then finally the merging keeps on happening until we get the final array, which is like the big array. Okay, so this is basic of merge sorting, and let's get started with the code. So if we start from this point, we need a split function which splits into one unit, like one array of one length. So we will just quickly write merge sort, which takes an input as array, and I'm using arrow function for this. Arrow functions are pretty convenient in JavaScript. You can use whichever language you want. It's just that arrow functions in JavaScript are really great, so I'm using that. And now before going into a recursion, I want to make sure that I go and have my boundary check, which is array if array.length equal to 1. If this is the condition, then you want to return array. Okay, otherwise I want to split it, so I want to find the mid index, which is like math.floor of array.length by 2. So say if my array length is 10, it will give me 5. If it is 9, it will give me 4, because it's a floor, and so on. Okay, now I've got the mid index. Now I want to split it, so I simply use left array equal to array dot slice, and I want to slice it from the very first element till the mid index. Okay, so yeah, like this is the simple syntax to slice anything in JavaScript. In Python, it's like indexing, I believe, 0 to mid index. Yeah, it looks even more simpler in Python. And then you have right array dot slice mid index, so mid index and beyond. Similarly in Python, it will be mid index and beyond. Okay, so this is basically for the splitting. And now moving on, we got the two halves. Now we want to check. Now we want to keep iterating this condition until we reach the array length of 1, because it is all about divide and conquer. You want to reach to the very first element, not very first element, basically the element of length 1, and then you want to start from there and start merging. Okay, so we will now return merge sort, and not merge sort exactly, it should be return merge basically we are doing a merge operation, right? So we will have to handle it into another function, and inside this merge sort we have two halves, so basically the left array and the right array. But we want to make sure that these arrays are, they reach to their elemental level, which is like one array with length 1, and for that we will be using recursion. So here we will add merge sort. I hope this is a bit confusing, but I hope like you're getting an idea, and I'll just give a quick example for this as well. So let's say you have an array of like 2, 4, 5, 6. Okay, now once it enters this, it checks length is equal to 1, which is not. It splits the array, it gets the middle index. In this case it will be 4 by 2, which is 2. So the first half will be 0 to 2, the second half will be 2 and beyond. So 0 to 2, which is like 2, 4, and the 2 and beyond is 5, 6. So it will come here, it will merge, which we will be defining. But the merge sort will again do 2 to 4, it will go and again go do the same process. And in that case it will just go like 2, 4. And it will again split it into two halves. So one will be, because it's 2, so it will be 0 to 1, and the other one will be 1 and beyond. So basically it will again split into 2, 4, and when it reaches 2, 4, which is like in this case, then it will return this array, which is 2 and 4, and so on. Okay, so that is the idea behind splitting it into elementary position, which is like an array of length. Okay, now let's define our merging operation. So merge, which takes two parameters, left and right. Okay, now we want to merge it as we discussed here. So the idea is define two pointers. So left pointer equal to 0, and then we have let right pointer equal to 0 as well. Okay, now we will start from 0. We will keep on iterating until we reach the end of one of the arrays. Okay, so until one of these arrays is covered, then we will simply use a spread operator or simply concatenate it to merge the result of the rest of the element. Okay, so here we will, because we don't know what is exact condition, so we will be using a while loop. So while left pointer less than left dot length. Okay, so we will keep on iterating until we reach left dot length minus 1, which is like the last element of the left array, and right pointer less than right dot length. Okay, I hope you got this idea. So basically we will keep on iterating until we reach the end of any single array. Okay, and we'll do the comparison here. Once we we do the comparison, and because we want to put it into a specific array, so we will just have a result array which will keep these values. So we'll keep on doing the comparison until we reach the dead end of the one array. So okay, so I'll do left, I think I should be more specific here, left array and right array. Yeah, this looks better. Left array of left pointer, if left array of left pointer less than equal to right array of right pointer. Okay, so what we are checking is if the left array, the element of left array is less than equal to, because either we can use less than or we can use less than equal to, because we have to consider all three cases, less than, greater than, or equal to. So in this case it doesn't matter, it can come from the first left or right, it doesn't matter, so I'm using less than equal to. Okay, so if this is the condition, then I want to put result array, and I'll just quickly scroll up, push. Now here I want to put left array dot left pointer, and don't forget to increment the left pointer because we want to keep moving, otherwise this will result in an infinite while loop. Else, now if this condition doesn't meet, then we are sure that it's definitely the right array element which is smaller. So what we will do is result array dot push right element dot right pointer, and then we will do a right pointer plus this. Okay, so this is all about while loop. So what it is doing is it is comparing the elements of left array with the right array, and at the point where any of those array terminates, then we are going to concatenate the result. So we will return a result array. Okay, and we will concatenate. Now in this case we don't know which array has terminated. Okay, whether it is left array or whether it is right array. So because we don't know, so we will be concatenating both of them together. Okay, so whichever has reached the end, that will be not appended, and the other one will be appended. Okay, so I'll give an example also. So if I say left array, and then we want to slice it for the remaining elements. Okay, so we want to focus on until the point where pointer has moved. So let's say pointer has moved from 0 to 5 and the element array length is 10. So 0 to 5, and then from 5 to beyond we want to add concatenate as it is. Okay, so here I will write simply left pointer, and similarly here I will write right array dot slice right pointer. Okay, so let me give you an example. So let's say we have an array which is like 2, 4, and here we have 8, 12. Okay, I'm so sorry. So here what will happen is the comparison will begin with 0 for the both the pointers, 0, 0, and as you can see 0, 0, while left pointer it will enter the while loop. Left pointer, which is 2, is less than equal to 8, which is true, so the result array will push in 2. Okay, and now 0, this will become 1. So now 4 is again less than 8, so it will again push, and now this will become 2. Okay, and since this condition is violated, so it will exit out the loop, and because this is 0, so now we will have the second array, which is okay, yeah. So coming here, concatenate, this is result array, so left array dot slice left pointer. So left array dot slice left pointer is basically 2 and beyond, and because there's nothing beyond, so it will just concatenate an empty array, which is similar as concatenating nothing. Okay, and similarly for the right array, it will start from 0 and beyond, which is 8, 12, so it will concatenate 8, 12, and this will result in this, the array which we want, which is 2, 4, 8, 12. Okay, so this is the idea behind the merging operation, and this will keep on merging, and yeah, like we are getting the splits, and we will keep on moving to the elemental level, and then we will keep on merging them together to get what we want. Okay, so now let's quickly test it. So I'll just scroll it down. So console.log merge sort result equal to, and then we have merge sort, and let's pass an array, let's say 3, 40. Let's type some random numbers, and here I will add 22. Okay, so I hope you got the idea. Let's see if it works. Not index, I think it's merge sort.js, and we get an error. What exactly is the error? Left is not defined. Okay, yeah, because it's not left anymore, it's left array, and similarly it's not right anymore, it's right array. Okay, so let's clear it up and try it once more, and we get the result 2, 3, 3, 5, 22, 24, 35, 45, 45, which is expected. So I hope you got this idea of merge sort, and I hope it is pretty straightforward for you now to understand it well and how it is implemented and how the recursion is working. Recursion is like a very powerful and strong concept. It can help you solve lots of problems, and if you use it carefully, because sometimes call stack keeps on increasing, because recursion is basically n to the power n, and which is like which can be very expensive. You can use dynamic programming concepts to cache in some values so that we avoid such situations. But other than that, recursion is pretty helpful even in web development. Like if you have a nested component, like for example, if you have a row component, and within row component you have another row component, in the front-end development in JavaScript, it's really useful to use a recursion pattern where you can keep on nesting like JSON-like structure, and it keeps on rendering element. And yeah, that is a very powerful concept. Other than that, it's pretty much used in many navigating to file directories, clearing files, and yeah, it's very useful concept. So I hope you like this video, and if you want, you can quickly try to implement the same in Python as well. So we will have define merge sort, where you will pass an array which will be list, and this will return the list and array. Okay, I think because of first line I was getting that error, so I'll just quickly do this array, and then we have list which will be returned, and we need to check if len of array equal to 1, in which case we want to return array. Otherwise we want to find mid index, which is like int of len of array, and because I'm using it as a function, I'll store it into another variable, which is array length is len of array, and I'll use it in other places. So I'll replace here and here as well, array length by 2. Now left half equal to array of 0 to mid index, and right half equal to, and I should be more specific here, right half equal to right half to array of mid index and beyond. Okay, so we have our arrays ready, and we will use a return function which will have a merge, and it will have merge sort, and it will have left half, and we don't want the right half here, so we will have a merge sort of right half. Okay, and we need to quickly define merge as well. So define merge, and here we will have left comma right, and again these two are list of numbers actually, and this will again return a list. Okay, and yeah, so first we need to have left pointer which is equal to 0. Similarly, right pointer is equal to 0 as well, and now we will iterate while left pointer less than equal to, and we will just have left length. So left length equal to len of left, and then right length equal to len of right, and result equal to empty. So left pointer is less than left length, and here we will use right pointer less than right length. Okay, and if left of left pointer less than equal to, and let's be more specific here as well, so we will say left array and right array. So I'll quickly replace wherever it's supposed to be replaced. Okay, dot right pointer we will append result dot append left array dot left pointer, and we will also do a increment which is left pointer plus equal to 1, else result dot append right array of right pointer and right pointer plus equal to 1. And yeah, once we are done with this, we want to return an array which has like result comma which has left array from left pointer and beyond, and we also want to split this, and right array right pointer and beyond. So yeah, I think this should work. Okay, let's try it out. So if name equal to main, array equal to, let's have the same array which we had there. Okay, and then we do print merge sort equal to merge of array. Okay, I hope this should work. Let's try it out. So we call python merge sort by. We get an array merge. Okay, sorry, it's not merge, it's merge sort. And here I'll just quickly do a positional argument thing. So just to be super sure, although this won't change anything, but yeah. And here also let's do a simple. Okay, now let's try it out. And as we can see, the expected results are same. 2, 3, 3, 3, 5, 24. So yeah guys, that was all about merge sort, and as you can see, it's very simple and straightforward once you break down the concepts and try to implement. I hope you like this video and I hope this was useful. In case if you have any questions, feel free to ask me. I would be glad to help.